Imagine you are standing at Liberty Island, home of the Statue of Liberty, at night. You look out towards Manhattan and see the glittering lights of the buildings above the water. It is so bright, even though it's dark outside, and the water reflects the light, creating a glow unique to the city. You are able to see this incredible view because Manhattan is an island. In order to create that glow, the buildings and structures of New York City require energy, and lots of it. As it is now, the 5 square miles of Midtown Manhattan use more energy than the entire 225,000 square miles of Kenya. That's 45,000 times more energy. As anyone who has been in the ocean can tell you, water is extremely powerful. But when storms come through the city, they can jeopardize the energy grid. In some cases, such as 2012's Hurricane Sandy, the strength of the hurricane caused Lower Manhattan to have a horrible blackout. Millions of people were left without the security that electricity can offer and were forced to abandon their homes in the quest to find electricity elsewhere. This storm and blackout raised the important question of how can we power the city in a way that is resilient to problems like the ones posed by Sandy. The answer to this complex question could lie in the problem itself, the waves. The water surrounding Manhattan is generally split into the East and Hudson rivers. The East River is technically a tidal strait, as it is connected to the New York Upper Bay, the Long Island Sound, and the Hudson River, and is heavily influenced by the tides. Because of this, it is extremely predictable, and it floods north and east and ebbs south and west. On average, the East River has a speed of about 5 knots, depending on the lunar cycle and the weather. Water, especially predictable water, is an extremely dense form of energy, meaning that a large amount of power could be generated from a single wave, especially during a storm. Waves are a continual source of energy because they move over and over again. Capturing energy from waves and tides seems like it would be extremely difficult. However, the principles are relatively simple. As water pours through a turbine, it spins the blades, which is attached to a generator module. From there, the mechanical energy is converted into electricity and carried via wire to the city. Each turbine has the ability to generate 10 megawatts of electricity, or enough to power 10,000 high-use households. In order to create the amount of energy needed to supply the 230,000 households in Midtown Manhattan, we would need 23 turbines. These turbines are relatively easy to install as they sit on the floor of the ocean and collect energy from the tides going through them. In order to best collect the energy that is in the waves of the river, it would be best to place the turbines near Roosevelt Island in the East River. Around Roosevelt Island, the speed of the water increases, increasing the potential for energy collection in that area. Additionally, the site is beneficial because it is close to Manhattan, so not much energy will be lost in bringing the electricity into the energy grid itself. With this system in place, New York City has a chance to remain powered, even in the midst of an environmental disaster. It is likely that during such an event, other ways of electricity generation, such as nuclear generation, would be cut off. Because of this, it is crucial that the energy used in New York City is renewable. With a difficult enough disaster, the energy availability in New York may be slowed or stopped for days or even weeks. By linking the turbines to the grid, New Yorkers could have another option for where the energy they produced could go. If conditions allowed it, the energy from the waves could be used to power the subways, which would enable people to leave their homes for somewhere safer if that needed to happen. In peak hours, the subways of New York City use about 495,000 kilowatts of energy, which is equivalent to 495 megawatts, or the power of 50 turbines. If half of the subway lines were in use, water energy could be the sole provider of power for the subways. Overall, the usage of wave energy is not only clean, it is necessary in instances like this, where safety and electricity can so often be intertwined. Not only will this addition of a turbine farm in the East River help power New York City using renewable energy during day-to-day life, it will also greatly impact the efficiency of the city during the storm. New York can keep on glimmering even if the storm is attempting to disagree.